Welcome to Ask and Learn.
So in this question, we have a capacitor plate that is initially charged and then it from the battery. So let me just write some of the key information. So what is the charge on the capacitance? Well, Q equals C times V. Then we figure out what is the capacitance or not times area over distance. And then asks plate is now pulled to a separation of 0.5 millimeter. If it goes 0.75 millimeter, what is the charge? The voltage much, and the capacitance if it's pulled apart, the capacitance changes and the voltage will change, but the total charge is the same. And then part C, what is the potential difference across plate now? Well, it's Q over C2. Now we have a different capacitance because of distance. And D asks how much work required to pull it from separate to pull the plane to the new separation. So we're looking for delta U. So that is half of we can write this as Q squared over. So we have C1 minus C2. So that is the idea of this. Now let's actually work out the numbers. If we look at this question, at first, this is literally just calculating the stuff. We have 5 times 10 to the negative 12 farad per meter times 2 centimeters squared. That is 2 times negative 4 meters squared. 0.5 millimeter is 5 times 10 to the negative 4 meter, and times 12 volt. And this is 0.25 times 10 to the negative 11. So that is capacitance. The amount of charge, the amount of, coulomb. So that is around, 4.42.5 picocoulomb. So that is the amount of charge stored in this capacitor. And then so for part B, it doesn't change. It's the same number. It's 4.25 times 10 to the negative 11 coulomb. Now part C, what the new capacitance is. The easy trick is to just use a ratio because capacitance is inversely proportional to the distance. So C is proportional to 1 over D. What that means is that C is a constant. So C1 D1 will equal to C2 D2. So from that, we don't actually have to calculate. You can just write it as C1 D1 over 2. That saves us a little bit of trouble because then we know what C1 is. It's just V is 12. So it's just V1 times D1 times D2. So it's 12 volt over 0.5 millimeter times 0.75 millimeter volt. You can also just put C2. It's just easier to do it with the ratio. So finally, we have this. Now that we've actually worked out some of the numbers, I feel like it's probably easier to use V instead of C. So I'm actually going to use of 1/2 times Q delta V. So 1/2 times 4.248 times 10 to the negative 11 coulomb times the change of voltage is 6 volt. So that gives me 1.3 times 10 to the negative 10 joules. That's the amount of energy is the amount of work we put in before pulling plays apart.